Now I'm going to continue with that change of variables or use substitution, but I'm going to work a couple problems where we're being asked to find the definite integral. So still that same process, but we'll have that extra step where we need to evaluate that. Okay, so this will be questions number 10 and 11. All right, so I'm noticing how my inside function is the x to the third plus 8. So that's what I'm going to let be u. So the derivative would be 3x squared. Derivative of 8 would be 0. And I'm going to go ahead and write it in differential form. Instead of du dx and then moving it, I just did that. So see this x squared and that dx, that's this part. But I don't want that 3. So I'm going to multiply by 1/3 so that I can see what to put in place of this x squared dx. Let me go ahead and do a little more rewriting on the original problem so you see it better. I'm just going to move that x squared over to the end so you see it sitting there with the dx. So I'm going to be replacing this, and I'll replace it with 1/3 du. I'm going to replace the x to the third plus 8 with a u. Haven't done anything yet as far as integrating, so I'm going to keep that -2 and 4 on there. Okay. All right, so now I'm going to go ahead and do a much simpler feeling integration. In fact, let me do one more rewrite. Let me put the constant out in front, because that constant can just be brought along. And then that u squared would have come from a u cubed with a 1/3 needed out in front. Now don't get mixed up. I put the 1/3 there so the 3 would have knocked it out, but this 1/3 was already there. So I still need it. It's still going to be part of the problem. So that's going to turn out to be a 1/9 u to the third. Okay. Now here's the little subtlety that I want to take a moment to talk about eventually. I do need to evaluate this, but I don't want to put these original limits of integration on it because those are x's. Those are x of -2 to an x of 4, and I'm not in x mode yet. I'm in u mode. So I do have some limits here, but they're not -2 to 4. So wait to plug in on that. You could just leave them open like that and wait to plug in until you get back to your x's. So once I get that x to the third plus 8 back in there, then I can put the -2 to the 4 back on. Okay. So then I'm going to need to take the 1/9, plug in the 4 for the x, then subtract 1/9, plug in the -2 for the x, and see what that turns out to be. Okay. So let's see, that's going to turn out to be kind of large. So it's a 1/9, that's 64 plus 8, 64 plus 8. So that's a 72 to the third. And then here, -2 times itself 3 times is -8. But then I have a plus 8 that has to happen before I cube it. Ooh, I like that. That turns that part into a 0. Right, all that part, that whole end piece is just going to be 0. And so it's really just going to be whatever 72 to the third turns out to be, divided by 9, and that's going to be 41,472. Okay. Now, note, it's kind of fun. Something else you could do. Let's see if I can get back. There we go. All right. I want you to note you could change the limits of integration to u values. Okay. So you could do that. Let me make this a little smaller so you can see way over here. So see right here? What I could do is when I'm working through, I really shouldn't have had the u, now that I see it, I should have taken those limits off right there. I should have remembered I had something, but they're not -2 and 4 until I get back to x's. So I don't even like them there once you kind of forget about them there. But what I could have done, I could have translated it like here. Let me get it to where I have the 1/3 in front. This is really fun, so if you're interested, just take a moment to think about this. What I could have done is figured out what these would be in terms of u's. Okay? So I know that I let u equal x to the 3rd plus 8. Now that bottom limit was a -2. So if x equaled -2, then u would equal -2 quantity cubed plus 8. U would have been 0. So that means this bottom limit in terms of u would have been a 0. Now, I could use that same rule, and if x equaled 4, plug the 4 in, and 64 plus 8 is 72, then this would have been a 72. Okay, so this is if you decide, if you think about it, it makes sense to you, you could change the limits of integration to be the ones over here that go with x's. Okay, that's in terms of x's. Okay. Right, so these beginning ones, you could change them so they're actually u's, and then here's what it'll do for you. Then when you integrate, you decide that's going to be a u to the 3rd with a 1/3, with the 1/3 that was already there. You can just evaluate that from 0 to 72. So that's 1/9 u to the 3rd that I'm evaluating. So 1/9, 72 to the 3rd, minus 1/9, 0 to the 3rd. It is precisely the same amount of work. It's just whether you work out the -2 to the 3rd plus 8 over to the side and get 0, or whether you do it right here. Okay? And same with the 72 piece. You see how this part right here becomes the 72? Well, that's because I'm working that out right here. So it turns out to be the same thing. You'll still get your 41,472. Okay. All right, let's try one more of those. Definite integrals. These are definite integrals with algebraic functions. All right, so I got to do some rewriting on this one. Just want to see better what's going on, so I want to make it a power function. So that 1 plus 2x squared has a square root, so it's a 1/2 power, but I want to bring it back up to the top, so I'm going to use a -1/2. I'm going to move that x off to the side rather than being up on top like it was. And then I'm going to think about how I'm going to let u equal the 1 plus 2x squared. Then du would equal 0 plus 4x dx if I went ahead and wrote it in differential form. Now I'm seeing where I want to make my substitutions. I want to put a u there, and I want to replace this x dx. So I want to see what to substitute in for that x dx. So I'm going to just multiply by 1/4 on both sides to get the x, what the x dx would be. All right, so x dx I can replace with 1/4 du. The 1 plus 2x squared is the u. And then here's where, if you wanted to, you could leave these open Or you could figure out what they are in terms of u at some point. It's really just up to you. Let me try showing you again how to get those limits of integration changed. So if x were 2, then u would equal 1 plus 2x squared with a 2 where the x was. I'm looking at this. So that would be 1 plus 2 times 4, 1 plus 8, which is 9. That means where the 2 was, I could put a 9. All right, then if the bottom limit is 0, that really means x is 0. Then let's see what the u would be. U is 1 plus 2x squared. So 1 plus 2 times 0 squared, which is 1. So I could put a 1 there. So it's not hard to do, and it can be kind of fun. So that 1/4 is a constant. I'm just going to put it in front. I'm going to do my integration now by adding 1 to the negative 1/2, which gets me a positive 1/2. But when that comes down, I would need a 2 to make it go away. And then the 1/4 constant I need to carry along, the 1/4 that was already there, I need to bring along. And I've already changed my limits of integration to be in terms of u's. So I could really go ahead and start simplifying a little and then evaluating this. So 1/4 times 2 would be 1/2. And u to the 1/2 is just square root of u. And I just need to plug in a 9. And then subtract what happens when I plug in a 1. So I get half of 9, which is half of 3. I get 3/2, minus half of 1, which is 1/2. Ooh, I wind up getting 1 when I'm done. Get 2/2, which is 1. So that would be my final answer on that one. Okay. One comment I want to make is that if you wanted to just leave these open here and here, right, just leave those open, you could. It's just that when you are then needing to evaluate, you would put your x back in and then use your original 0 to 2, and you'll wind up just doing all the work we did over here ahead of time would wind up being part of your evaluation process. See how that 1 plus 2 times 2 squared, that's going to be your 9. Okay, that's the only difference. So both ways work. Both are going to give you a 1. It's just whether you want to do this work right here ahead of time to find out what the limits of integration would be with respect to u, or whether you want to just have placeholders there and then get the u, get it back to being x's so you can use your original limits of integration.